Hello everyone. Finally this video, it will be why the MLOps, before defining what MLOps is. So what's happening is that in companies, often this type of project involving deep learning and exposing APIs in real time fails. Why do they fail? Because there are a lot of issues to deal with. And you have to realize that once you've set up a project, you also have to keep it going. In other words, incidents can happen, typically a problem with the infrastructure that needs to be rectified quickly, or there may be, as we'll see later in more detail, data drifts or even a very sudden data shift. So we need to be able to retrain our AI, but very quickly, to be able to repair production. So that's one of the reasons. Another reasons, there's also the fact that these projects are generally very expensive, i.e. they cost a lot of money, because you need a training environment which generally uses CPUs, GPUs, lots of processors and lots of RAM, all of which are very expensive. We're adding complex data-related workflows to traditional IT projects. And above all, one of the biggest reasons is that we're adding more players. In other words, today we hear talk of DevOps projects, meaning that developers work with ops, and it's not easy enough to get several different profiles to work together. And now we're going to add, in our case, a set of profiles associated with data, which makes these projects even more complicated. Here's a little Google diagram with boxes. What you need to understand is that today almost 100% of a project is code. And here, if we take the little blue box that allows you to write data science code, what you need to understand is that it's just under 5% of the total project. And here, you really have to understand that if all the constraints, if you do your job in this little box, but all the constraints of the other little boxes aren't resolved, the project won't go into production. So it's very important to understand that if the constraints of others are not the constraints of yourself, it won't work. Among the constraints, there's also what I call the Bermuda, i.e. in data science, when we model an AI, we focus on getting good prediction rates to know whether our project is feasible and on getting them as high as possible. However, these are not the only constraints to be respected. What happens is that on these training environments, we can generally have machines with 80 CPUs and GPUs, but in production, we may not have such machines. And so, on production machines, response times may be longer. So imagine that for my cats and dogs, for my classification, we want to respond in less than 2 seconds. And we end up in production with a model that lasts 10 seconds. Right away, I've got a problem, and I'm going to lose a lot of customers. So there's a triptych of choices to be made on a permanent basis between prediction quality, response times, and infrastructure costs. Because yes, I can put big machines into production, but that will cost a lot more. And among the problems, there's one that's still the biggest and the hardest to meet, is that when you work on a training environment, you work in batch mode. And typically, on this project, we're going to have what we call pre-processing before executing our AI. So we'll extract the images from our PDF, and then each image will give it to our AI, which will give us a prediction. And for our AI, we're not going to give it images with millions of pixels. We're going to reduce the image before that. Well, what happens is that if we make a modification in the pre-processing, for example, on the production environment, but you don't have exactly the same code between training and production, what will happen is that we'll have no idea what's going to happen in production. Basically, the complexity is that if we have a tiny pre-processing diff between the train and production, our project won't work. When I say diff, we can talk about the version of Python, the version of the libraries, the code, and if we don't have exactly the same thing, it doesn't work. Here's a little demo. In other words, to resize images, to give them to the AI in 224 pixels times 224 pixels, by default in training we use Pillow, but Pillow is a rather slow library, and we realized in production that OpenCV was much faster. On the other hand, we didn't retrain with OpenCV. Today we've trained the model with Pillow. So what happens is that I can take an image of a dog and run it. So here I have a dog, feedback loop, yes, and now I'm going to run my same AI, except that to resize the image, I'll use OpenCV. What's going to happen is that it won't predict the same thing. Here's a cat. So, do you agree with this result? No, I don't agree. And that's a real problem, because if I don't retrain my AI with my OpenCV version, I can't go into production with it. I can't go into production with the OpenCV version. This means that the statistics I get in training won't be worth anything at all, because I don't have the same code at all in production. As a result, I don't know what I'm delivering in production. So that's all for this video. And normally for the next video, we'll talk about what MLOps are.